When we talk about area, we're asking, how much flat surface does a shape cover? Imagine you're painting a wall or tiling a floor. You need to know the area to buy the right amount of paint or tiles. We always measure area in square units, whether it's square feet, square inches, or square meters. This helps us visualize the two-dimensional space inside the boundaries of a shape. The foundation for finding the area of every shape we'll study today is the rectangle. We learned in earlier grades that to find the area of a rectangle, you just multiply the length by the width, or as a formula, A equals L times W. Think of it like this. If you have a chocolate bar that's 5 squares long and 3 squares wide, you multiply 5 times 3 to find there are 15 total squares, or 15 square units. Why is this important? Because we're going to use this simple idea of the rectangle to figure out the area of every more complex polygon, from triangles to trapezoids, just by cutting them up or rearranging them. The simplest shape to find the area for is the rectangle. We learned early on that you just multiply the length by the width. For instance, if you have a garden that's 5 meters long and 3 meters wide, you multiply 5 times 3 and you get 15. The area is 15 square meters. Every other area formula we learn comes from this basic idea, either by cutting the rectangle in half or by rearranging parts of it. Now let's look at the right triangle. If you take any rectangle and cut it diagonally from one corner to the opposite, what do you get? 2 identical right triangles. Since one triangle is exactly half of the rectangle, its area must be half of the rectangle's area. That's why the formula is half times base times height. The base and the height are the 2 sides that form that perfect 90-degree corner. Here's a simple example. A right triangle with a base of 8 centimeters and a height of 6 centimeters. We put those numbers into our new formula. Half times 8 times 6. Remember to always multiply the numbers first. 8 times 6 is 48. Now, we take half of that, which is 24. So the area of our right triangle is 24 square centimeters. That means 24 small 1 centimeter by 1 centimeter squares would fit inside it. You might be wondering about triangles that don't have a right angle. Do we use a different formula? Nope. The brilliant thing about geometry is that the formula area equals half base times height works for all triangles. The key is finding the height. The height is the line that drops straight down, making a right angle with the base, even if it has to be drawn outside the triangle, like on an obtuse one. It's always the perpendicular distance. Let's practice with a non-right triangle that has a base of 10 inches and a height of 7 inches. The calculation is half times 10 times 7. You can calculate this easily by taking half of 10, which is 5, and then multiplying 5 times 7. That gives us 35. So the area is 35 square inches. See? It's the same simple steps no matter the type of triangle. A parallelogram is a 4-sided shape where opposite sides are parallel. It looks a bit like a rectangle that someone pushed over. To find its area, we use the formula area equals base times height. If you imagine cutting the triangular piece from one end and moving it to the other, the parallelogram becomes a rectangle. That's why its area is base times height, just like a rectangle. The height, again, must be the perpendicular distance between the parallel bases, not the slanted side length. Let's try a parallelogram with a base of 12 meters and a height of 4 meters. We multiply the base and the height, 12 times 4. The area is 48 square meters. If you were paving a walkway shaped like this, you'd need 48 square meters of material. The formula is actually simpler than the triangle formula, even though the shape looks a little more complex. The trapezoid is a 4-sided shape with only one pair of parallel sides. We call those parallel sides the bases, base 1 and base 2. The standard formula for a trapezoid is half times height times the sum of the bases, written as B1 and B2. This formula works because you can always decompose a trapezoid into two separate triangles, and then add their areas together. This formula is just a shortcut for doing that decomposition. Imagine a trapezoid where the parallel bases are 5 feet and 9 feet, and the height between them is 6 feet. First, we add the bases. 5 plus 9 equals 14. Now we use the formula. Half times 6 times 14. We can take half of 6 first, which is 3, and then multiply 3 times 14. 3 times 14 is 42. So the area of the trapezoid is 42 square feet. Rhombuses and kites are special quadrilaterals. A rhombus has 4 equal sides, and a kite has 2 pairs of equal length sides that are next to each other. The coolest thing about them is that their diagonals, the lines connecting opposite corners, cross at a perfect right angle. We can use the formula area equals half times diagonal 1 times diagonal 2. This is because both shapes can be cut into 4 right triangles, and the whole shape is half the area of the rectangle that surrounds it. Let's find the area of a rhombus where the diagonals are 10 millimeters and 16 millimeters. We use the formula half times 10 times 16. It's often easiest to take half of one of the diagonals first. Half of 10 is 5. Then 5 times 16 equals 80. The area of the rhombus is 80 square millimeters. Sometimes shapes are drawn on a coordinate plane. This makes finding the side lengths easy. You just count the units on the grid to find the length of the base or the height, and then use the appropriate formula. If the shape is irregular, you can use the coordinate lines to help you decompose it into simpler shapes like rectangles and triangles. The coordinates are like a ruler laid over the shape. The most important skill you'll learn in this unit is how to work with irregular polygons, shapes that aren't simple rectangles or triangles. We use 2 big strategies: composing and decomposing. Decomposing means breaking a big, complex shape into smaller, simple shapes you already know the area of. Composing means the reverse, putting simple shapes together. The goal is always to turn a tough problem into an easy one. Let's focus on the decomposition strategy. Think of a shape that looks like an L or a stair step. You can draw a line to split it into 2 rectangles. Once you have your simple shapes, you calculate the area of each part individually. Finally, you just add up all those smaller areas to get the total area of the original complex polygon. It's like finding the area of 2 rooms separately, and then adding them to find the total floor space of an apartment. In this example, our complex polygon is split into a rectangle and a triangle. The rectangle's area is 6 times 4, which is 24 square units. The triangle's area is half times 6 times 3. That's half of 18, which is 9 square units. Now we add the areas together. 24 plus 9 equals 33. The total area of the irregular polygon is 33 square units. This is a very common strategy for floor plans. The other great method is the subtraction method. This is especially helpful if decomposing the shape creates too many small pieces or weird decimals. The idea is to imagine the shape you want to find the area of and draw a large, simple rectangle around it that perfectly encloses it. Then, you calculate the area of the whole large rectangle and subtract the areas of the empty shapes that are inside the rectangle but outside your polygon. Let's use the subtraction method. The large rectangle around our shape is 10 units by 8 units, so its total area is 80 square units. There's one empty space, a triangle, in the corner. Its area is half times 4 times 5, which is 10 square units. So we subtract the empty area from the total area. 80 minus 10 equals 70. The area of the inner polygon is 70 square units. It's like finding the area of a cookie by subtracting the area of the bite someone took out of it. Knowing how to find the area of polygons is an essential life skill. Think about real-world jobs. An architect, a landscaper, or an interior designer all use these skills daily. Say you need to buy carpet for a room that isn't a simple square. You must break that room down using decomposition to get the exact area. If you underestimate the area, you won't have enough carpet. If you overestimate, you waste a lot of money. This is why learning about area is a real-life skill which you will use when you grow up.